So, my friends, this says a fast food restaurant wants to make sure that the average wait time of people passing through their drive-through is less than 4 minutes. They must not. I mean, if Chick-fil-A had this, they're moving some people. Or Cane's. Isn't Cane's real busy too?
Yeah.
You know what? We should go test this theory. We should all go to Cane's right now. All right, I'll drive. There's room on the roof. All right. So they're trying to test that their average is wait time in a drive-thru is less than 4 minutes. Random sample of 1,000 cars passing through the drive-thru produced an average wait time of 3.62 minutes with a standard deviation of 1.02. Use alpha equals 0.10. Okay. So I think a random sample of 1,000 cars is pretty darn good, guys. What do you think? I'm pretty happy about this. All right, explain why a t-test it's not a z-test. Oh, okay, so we have to do that, huh? All right, so anyone want to take a shot at this answer? Why it's a well, we're looking why is it a t-test, not a z-test? Anybody? Anyone know? We have the sample standard deviation only, not the total population standard deviation. So that's that. Hey, that might be. Oh, hey.
Hello.
Trying to sneak by. Good to see you. We're on page 115. So, hey, that might be hint, hint, nudge, nudge. Something that you might see on the quiz on Monday when I'm not here, or on the chapter test on Thursday next week. Okay? So just to give you a heads up on that. It might be, like, hey, why would I use a t-test rather than a z-test? Or it might say, we have this, what should we use? A z-test, t-test. Then they have like other ones, they're like, Q-test or RSTV, TLMNOP test, and you're like, that's got to be the one, it's the longest answer. All right, so let's perform the entire T breakdown. So for number 2, we're going to say we got to create our null, and we create our alternative. So our null is, we're thinking it's equal to 4 minutes. We're trying to look for less, so that's kind of the not less than. And then I'm not going to use mu. I'm going to use drive through, DT. How's that? And then they want it less than 4 minutes. Okay. Okay, so drive through time is what that is. That's in minutes if we had to get anything fancy there. All right, let's create ourselves a normal distribution best we can. All right. So 4 is going to be here. And then, we got to find the standard error. Standard error is going to be the standard deviation over the square root of the sample. So in this case, that's going to be 1.02 divided by square root 1,000. And if you use the calculator, you're going to find that comes out to 0.032. So we'll call it good at 0.03. Sound deal? All right. So 4.03, 4.06, 4.09, 3.97, 3.94, and what did I do? Okay, I can slow down. You got it. 403, 406, 409, I think it was. Yeah. Yeesh. I got to learn how to write more clearly. Shh. A little too much talking, my friends. All right. We good there? All right. So they told us we want to deal with this alpha of 0.10. Hey, do I double the alpha or is this a one tail? This is a one tail. So they said that we had this 3.62 average. So that's like down here, way down here, right? Wow. Friends, I'm kind of sort of thinking in a little tiny bit of way that, yeah, okay. So this is what I goofed up on yesterday, and I'm sorry. We want to get the t-score, not the p-score, because you're using the t-table. Okay? And this takes us back to the day of doing a z-score, where you had your observed value minus your mean over your standard error. This is what I screwed up on yesterday because I couldn't remember how to do it. So I went to Mr. Anderson. I Googled it first because Google seems to be like the good go-to. And then I went to Mr. Anderson. He clarified it for me. So I feel so much better about myself. I actually clapped. I applauded for myself. So you guys should be proud of me. All right. But, all right. So if we're going to do that, if I go 3.62 minus 4, and then I divide that by 0.032, this is going to give me a t-score of negative 11.875. Okay. So, my friends, this is what we're going to plug into Desmos. Okay. So, does everyone agree that that 3.62 of our sample is like way far to the left from what we knew? Okay. So they want less than 4 minutes. They did a random sample, and they realized the cars are only weighting 3.62, standard deviation of 1.02. That's all great. We had to use 1.02 to find the standard error because we have a sample. We did all that. So we have this t-value. Now, hey, friends, does anyone want to take a guess how small our t-value is going to be?
Very, very small.
Yeah, I mean, we're at 4, and we're counting by 0.03, and we need to get all the way to negative 11.875. So I'm pretty confident, without even doing a whole lot of math, that we are going to reject our null hypothesis. Okay, but why let Stirrup's knowledge help us? All right, t distribution. All right, let's see who was paying attention. So, friends, we have a random sample of 1,000. Agree? Yeah. What is my degrees of freedom? 999. What's jumping in? So, does everyone feel comfortable getting the degrees of freedom being 999? Because the degrees of freedom is one less than our sample size. Our sample is 1,000. Yeah. Okay. All right. So 999. All right. So here is our wonderful t-distribution based. So I have a question for you. This is not on the question there. Friends, do you think that a t-distribution of degrees of freedom of 999 is really close to a normal distribution, or is it really far away? Let's just for laughs and giggles and showing that Stirrup has some sort of comprehension of what he's doing. So normal distribution of 0, 1. Friends, okay, the blue, normal distribution. The red. Yeah, I mean, I guess the only way you could do it is like if we do this, like if we zoom in like a jillion times. Oh, look, it's still off a little bit. Shame on us.
You have to throw it all out.
So throw it in the trash. Go away. All right, so we didn't really have to do that. I just wanted to show that it could be close, but then all of a sudden we zoom in 100 jillion times, and we realize it goes back. All right, so t-distribution, cumulative properties. So ready? So my left bound is going to be negative infinity. And I'm going to go at negative 11.875. Okay, my friends. You guys heard of Avogadro's number? 6.02 times 10 to the 23rd power.
Yeah, I know.
Okay, the number of molecules in 1 mole of a pure substance. Well, this is 8.1 times 10 to the negative 31st power, which basically means I have a decimal with 30 zeros followed by 81. My friends, do you think, is that, okay, we're going to see who's paying attention. Negative exponent means that I have a whole lot of decimals in there. Is that a bigger number than 0.10 alpha or smaller?
Why is it just a little bit smaller?
What's that?
Why is it 1.875?
Oh, that was what I had to, that's what I goofed up on yesterday. I forgot to teach it. What is it?
I thought it was 11.75.
Oh, is it?
Yeah.
I do have it there.
Oh.
I had to squeeze it in. Yeah. Okay. Yeah. My friends, this doesn't get much closer to nothing. You know, if someone says, hey, I'm going to offer you $10 trillion, but you only get 8.1 times 10 to the negative 31st multiplied by it. Like, you're getting nothing. You get nothing and like it. All right. All right. So, my t value was, what did we say it was? 8.1 times 10 to the negative 31st. Okay. So this right here. This is so small that we are going to reject our null. We might have found the strongest evidence ever. Strongest. Against our null. Okay. I mean, that's about the only thing I can say. I mean, since we're based on a p-value of 0.10, we reject the null. I mean, this is the strongest evidence. This truly means that this company is satisfying the less than 4 minutes to the drive-through. We got to check out this restaurant. That is a really bad restaurant. There's never everybody ever there, but you never know. All right, so down at the bottom it says, even though a random sample is used, is there another potential problem with the sampling method? Well, we're testing drive-through, right? So we're not worried about the people that come into the restaurant. Agree? Yeah. So we did a random sample of cars passing through the drive-through. Now, was this a random sample of all the stores nationwide? It didn't quite tell us that, but who knows? I mean, I think this is a really good t-distribution problem. I don't think there's any too much problem with it. All right, how do we feel? Feeling okay? Anyone crying themselves to sleep yet? Okay. Sorry about that.
For number 3,
Yeah, I don't have one bad thing to say. It's got a huge random sample. It's good. All right. According to on the backside, according to census data, census. That means we've got the entire population. Wow. The average age of an adult when having their first child is 28.2 years old. Okay. Statisticians wonder if this age has changed since the census. A sample of 25 Coloradans shows an average first child age of 28.6 with a standard deviation of 3.8. All right, so my friends, is there any red flags that you see as part of this right now? Who was a part of the census? Who was part of the census? Yeah, everybody in the United States. But one thing I see a problem with, sample of only 25 people, smaller than 30. Okay? We're only isolating Colorado, like maybe Colorado, people don't want kids or something. I don't know. So there's a couple of red flags here, but it's not going to prevent us from doing our math. We're not going to let a couple of red flags stand in our way. Not this week. All right. Hey, guys, did you get me a good note yet so I don't have to go on Monday, be here for you guys?
I'll write it.
You know, what I really need y'all to do, if you get a chance, you need to talk to Principal Silva saying, we really need Mr. Stirrup here on Monday and not to go to that training because we're working on the hardest thing in statistics that I've almost grasped. And I think if he misses a day, we're just going to miss out on our learning, something really good.
Yeah.
He'll care. He'll listen to you guys. He won't listen to me. But I don't blame him not listening to me. All right. So, everyone understand? So, this is a, let's see. Is this a one or a two-tailed test? It is a two-tailer, yeah. This is two-tail. So, we're looking for like a difference or a change. We're looking for like, is there a change in birth rate or birth year or something like that? Age of somebody plopping out a kid. All right, so we're focused on change. So we have a two-tail situation. Okay. All right, so problem number 2 for our null hypothesis and our alternative. Okay, we're going to say birth equals 28.2 years old, Y/O. And then birth is not equal to 28.2 years old. Okay. We have a sample of 25 people. The sample showed years old being 28.6. We have a standard deviation of our sample of 3.8 years. Friends, is this going to be a T distribution? And why or why not?
Yes.
Yes, it is. I like it.
Because it says so.
Because it says so? Because it's the chapter we're working on? What is the one thing that indicates a T distribution that's up there? See that right there? I highlighted in yellow. That's the standard deviation of our sample. Agree? Yeah, if it's a standard, this is of our sample. So this means T test all day long. You notice I'm kind of focusing on that because I know that question's coming up. Standard deviation of your sample, T test all day long. All right. Let's see. We got to make ourselves this fancy dancy normal distribution. It looks like this. Oh, it's so pretty. All right. And then we know that this right here has to be 28.2. And we have to find the standard error because that's what we're supposed to do. Standard error is the standard deviation over the square root of the sample. So that's going to be 3.8 divided by square root 25, which is going to give us about 0.8. Okay. So that means that's 29, 29.8, 30.6. And then that's going to give me 27.4. That's going to give me 26.6. And that's going to give me 25.8. Looking good, looking good. All right. So we need to find our T value, our T score. okay, which this is going to be, what did I say? It's going to be our observed. This is going to be our average minus the observed minus the mean. I'm sorry. It's the observed minus the mean over the standard error. So our observed, we observed wrong side of the paper. We observed 28.6. So 28.6, just so you know, 28.6 is like in here. So for that far above, being it's two-tail, I need to go this way as well. So that's 0.4 above, 0.4 below, so that would be 27.8. Okay, we have to do this because it's two-tail. Okay, same distance from the mean. We're trying to show a change. So we're trying to find something to the right or to the left of our red lines. So our observed minus our mean of 28.2 over our standard error, in this case of 0.8, right? Uh-oh. Friends. Scared. I don't have a calculator. Don't be scared, Stuart. You know where to find one. Go. All right. Clear? 28.6 minus, okay, that's a 0.4 divided by 0.8. Oh, we got 0.5. Okay. So our t-score comes out to a nice 0.5. All right. Hang on, what did I do wrong? Oh my gosh. All right. So if we do a t-distribution, why is it 24? I think you're right. Yeah, sample -1, degrees of freedom. Good job. All right, so we're going 24 here. All right, so what did I find that t-score to be? 0.5? Yikes. 0.5. T is 0.5. All right, we can do this. All right, so I have to go one way or the other. So I'm going to make this infinity. And I'm going to make this 0.5. Ooh. So my friends, how many tail is this? 2. So I'm going to take 0.311 and I have to double it. Agree? So if I go 0.311 doubled, so 0.311 times 2, because it's two tail. So 0.622. All right. We don't have a value to go based on this. So we have to make sure that our alpha or our p-value or t-value is 0.05. Friends, is 0.6 bigger or smaller than 0.05?
Bigger.
This is bigger. So we what? Fail to reject the null. Did not. Oh, thank you very much. Oh, man, somebody's paying attention. So we're up into that because that's the two-tail. Good deal. And it's still, 0.6 is still bigger than 0.10. So it didn't find evidence or strong evidence against the null. That was awesome. What is the consequence of the fact that only Coloradans were used in the sample? There's 49 other states. Shame, shame. Agree? We good? Hey, what time we at here? Don't lie because I'll find out when the bell rings. Are you kidding me?
What was 3?
3.
On the first page.
First page. 3 on the first page. There's nothing to worry about. It was a really huge random sample. I was pretty happy with it. All right, so make sure your names are on those. Still with me on this adventure? And hand that in. And again, hey, would you please double check to see that you have everything in. If you don't, get it in. Start getting it in. Trust me, you have a test or quiz that you're missing. Waiting until after spring break isn't going to improve your score.